Sample problem 9.04. The figure shows the overhead view of the path taken by the race car driver as his car collides with the racetrack wall. Just before the collision, he is traveling at speed Vi, which is equal to 70 meters per second, along a straight line at 30° from the wall. Just after the collision, he is traveling at the speed Vf, which is equal to 50 meters per second, along a straight line at 10° from the wall. His mass is 80 kilogram. So here we have to answer for the first question, which is what is the impulse on the driver due to the collision. So first of all, let's just recall the formula for finding the impulse. What's the formula? The formula for impulse, because impulse is a vector quantity, so impulse J, which is equal to mass multiplied by V final minus V initial. So this is the formula, right? Now the most important thing, we cannot able to substitute the values directly here because the initial speed as well as the final speed is different, and also the most important thing, the angles are different. So here, if you see this diagram from the overhead view, what is exactly happening here? So let's take, this is the racetrack wall. So the car coming with, so better I can just make the diagram like this. The car coming with some speed. So let's take, this is the car. So the driver, he is driving the car. So it's come with a speed, it will hit the racetrack wall. And the hitting angle here is 30°. And after that, and also they mentioned the initial speed, which is 70 meters per second. And after the collision takes place, what happened? Your race car is going in this direction, and by that its final speed is mentioned here as 50 meters per second, and also the angle here they mentioned 10°. Now what we have to do, we have to find, if you want to answer the question for the first part, we have to find the most important thing, the x component of the impulse as well as the y component of the impulse. So how we can find? It's very easy. Instead of going for these four quadrants, better we can make this line extending to this direction. So by that, what will happen? The same angle will be here, right? So by that, we can easily find, so this is your V initial. Now, based on the chapters we studied in chapter number 3, vector, we have to find what is the x component. So what this is? V initial of x. This is V initial of y. Likewise here, based on this angle, this is V final of x. This is V final of y. Now it's very easy if you consider this diagram. So now we have to find the impulse for x component and y component. So finding the x component first. Finding the x component, what we have to do? We have to write this rule as J of x, which is equal to mass is a scalar, so we just separate, but here final speed, that means V f of x minus Vi of x. Likewise, we have to write the rule for the y component. How we can write the rule for y component? For writing the y component, it's very easy, which is J of y, which is equal to mass multiplied by V f of y minus Vi of y. Now we are going to substitute the value. The mass of the driver, they clearly mentioned in the question, which is 80 kilogram, right? So I am going to substitute the value here. So m value takes 80 kilogram. Now Vf of x. So let's come for here. What is Vf of x? Vf of x is this. So the Vf value is 50. So we have to consider the x component. So how we can write 50, or we can write one more steps, no issue. I can write Vf of cosine of minus 10° minus what is Vi of x? I can write VI of cosine 30 degree. That's it. So now I'm going to substitute the value here. 80. What is our VF? VF is 50 cosine of minus 10 degree minus what is VI, which is 70 meter per second cosine of 30 degree. So let's see what is the answer. 80 multiply with 50 of cosine of minus 10 minus 70 of cosine of 30 degree. I got the answer here as minus, that is our j of x, which is minus 910, and what's the unit? Mass multiplied by speed, which is nothing but kilogram meter per second. So this is our x component of the impulse. Likewise, we have to find the y component. So how we can write? We can write this as mass multiplied by what is your VF? Our VF of y, which is nothing but VF of sine of minus 10 degree minus V initial of sine 30 degree. Now I'm going to substitute the value. So 80 multiplied by V final is 50 meter per second. So sine of minus 10 degree, and your initial speed is 70, right? 70 meter per second. So 70 multiplied by sine of 30 degree. Let's see what is the answer for your y component of impulse. So 80 multiplied with 50 sine of minus 10 degree, 50 sine of minus 10 degree minus 70 of sine of 30 degree. So here I got the answer as minus 3494.5. So I can write 3495 kilogram meter per second. So this is the answer for the y component. Now what we have to do, we have to find its magnitude. So how to find the magnitude? It's very easy. J magnitude, which is equal to square root of j of x square plus j of y square. So now I have to substitute the value. What is our j of x? Our j of x is minus 910. So minus 910 square plus minus 3495 square. So here, let's see what is the answer. We can write 3612 kilogram meter per second. But anyhow, because they gave the answer, I think we have to give the answer in vector notation. How to write the vector equation for this impulse? So impulse is a vector quantity. So we have to write j of x plus j of y. So if you write, you can write j vector, which is equal to minus 910 kilogram meter per second I cap minus 3495 kilogram meter per second j cap. So this is in terms of vector equation. After that, we have to find the magnitude. But anyhow, we already find the answer for the magnitude. And also, if you want to find the direction, it's very easy. Already we know the formula, theta, which is equal to tan inverse of j of y component over j of x component. So tan inverse of minus 3495 divided by minus 910. I got the answer here as 75 theta, which is equal to 75.4 degrees. So this is the direction. Clear? Okay. Now we have to answer for the second part. What is given in the second part? The collision lasts for 14 milliseconds. What is the magnitude of the average force on the driver during the collision? So the rule we already studied from the theory class, the average force, which is equal to the impulse divided by time interval, right? So what is our impulse here? We already find the answer here as 3612. So what is the answer we got? 3612 divided by, and what's the time? 14 milliseconds. So 14 multiplied 10 power minus 3, because milli stands for 10 to the power of minus 3. So let's see what is the answer. 3612 divided by 14 10 power minus 3. We got the answer here as 2, can write it in terms of power, 2.58 multiply 10 power 5 Newton. So the average force, which is equal to 2.58 multiply 10 power 5 Newton. So this is the answer for the second question. That's it. Thank you.